Okay guys, just a really short video just to introduce this lesson. Unit 4, Lesson 5, Transformations of Trig Functions. By the end of this lesson, you can apply transformations to the graphs of sine x and cos x, and I believe that I put some examples, secant and cosecant, and understand the impact these transformations have on key characteristics of the graphs, such as period and amplitude. However, I will say we will be spending some more time later in this unit on the graphs of tan and cotangent, and then again applying transformations to secant and cosecant. So if we're not looking at secant and cosecant today, we will for sure in another lesson. So before you jump to the Desmos activity, let's just review transformations, because now we're looking at trig functions, but the transformations are the exact same. So when we have a value out in front, that is a vertical, stretch, compression, or reflection. This is the exact same rules apply when we are dealing with a trig function, and remember that this is a vertical reflection, so it's over the x-axis. It's the y values that are changing. This here is your horizontal. Actually, let's just save ourselves some writing and go up top and say that this is a horizontal stretch, compression, reflection, but now it's over the y-axis. And remember that k value has to be factored out in front. And then this here is your shift left and right, and we call it specifically a phase shift when we're dealing with our trig functions. So this is a phase shift, which is a shift left or right. But now we're going to be dealing with like phase shifts like pi over 4, pi over 2. And then this is a vertical translation. Okay, so vertical translation, which would be up or down. And remember that our current location of our max and min is 1 and -1. So we're probably not going too far. We might be going up 2 or up 3 or something like that, but we're not going, often up too many. So those are the transformations, just a quick review. And I want you to think about which of these transformations would have an impact or would affect the amplitude, and which of these transformations would affect the period. And so when we're thinking about that, the amplitude of the function is that distance between the max and the midline, or the min and the midline. So if this was our sine curve, this is our amplitude. So what would cause that amplitude to change, to become greater or smaller? And that would be a vertical stretch, okay, would cause the amplitude to become greater, or a vertical compression could cause the amplitude to become smaller. So these transformations here are going to impact the amplitude. Which transformations would affect the period? So if you think about the original period of a sine or cosine curve is 2 pi. So let's look at cos this time. We have 2 pi. What would result in the period changing would be a maybe horizontal compression. Now maybe the period is only pi instead of 2 pi, or a horizontal stretch where this is now the halfway mark and the one full rotation is over here at 4 pi. And that means that our k value, or our horizontal stretch compressions, will impact the period. So keep that in mind as you're going through the activity today. But the activity is, there's 2 Desmos activities. So this one here is the actual lesson, the trig function transformations, and you're walking through step by step. It's a really great activity, and you get a chance to check your understanding. And in the second activity, you get a chance to check your understanding, where you're actually applying the transformations based on your understanding of the original function and your understanding of the transformations, putting the dots on the curve, and then allowing Desmos to sketch the graph and see how accurate you were. Okay, so do make sure you do both of these. Very important. And that is it from me for today. Have a good day.